solving that out. Everybody should pretty much start off the same way. What's the first thing you probably did there was parentheses, right? Distributed property. So as we come back around and start talking about this, remember, we always start off with that as what we call given. I got to give Lucy an equation to solve. She may not want to take it, but I'm still going to give her an equation to solve. So that's our first reason it's called given. After that, it depends on the equation, right? So as Tyler said, we got parentheses, and to get rid of those parentheses is our distributed property. Absolutely, is where probably everybody should have started. Now, after that, all right, what's probably the next move everybody probably did after that? Combine like terms, right? Now, depending on how, you can write this one of two ways. I always tell my students you could just go easy and say the word simplify. That is cool. Or you could also say literally combine like terms. Either way is just fine. Yep. Simplify or combine like terms, cool. I'm fine with either one. Now, my Algebra 1 students are starting that topic this January. We're going to be into solving equations. Now, you guys are a little bit ahead of the game there, so you should be definitely more comfortable with solving equations. And when you clean these always up, usually they always go back to what we say is a two-step equation. So again, we are at this point where you should be able to look at these equations and run through them pretty quickly. If you're looking at these equations and they're not coming to you very quickly, tell me. You got to get some practice in there for you. Okay? But you should be able to tell me that two-stepper now. What's my first inverse operation? Thank you. That's what I'm looking for. A little quicker that addition is happening, right? We're adding 20 on over. And as we add 20 on over, what do we got? Negative 76. And as you said, the addition, what do we more formally call that? Anybody remember that? Not just addition, we call it a little bit more formal than addition. Yep, keep going there. Addition property of, anybody?
Equality.
Thank you. Almost there. We finally got it. Okay? So remember, on that reason side, it's nothing like very specific. Don't tell me you added 20. Don't tell me you divided by 3 or anything like that. We use those generic properties. Addition property of equality, multiplication property of equality, subtraction property of equality, or what's our last one? Right. We're going to divide now. And what do we get for our solution? I'm sorry? -8. 2 negatives, right? Yep. And those are those silly mistakes to watch out for, right? Negative 176 divided by -8. We all have calculators, all right? Let's make sure we're just double checking our arithmetic using those negatives because, man, oh man, those negatives will kill us. I did that reverse, didn't I? The answer is 8. I divided by 22. That's totally my bad. Get those cross-wired in my head there. That should have been what I did. And it gives me that 8. Okay? And then that reason is, again, a little bit more formal there. Division property of equality. So, with the justification there, that's what we're looking for our reasons. And we've used up all of our reasons. The only other reason that we didn't use was the subtraction property of equality and the multiplication property of equality. But those are all the reasons we use. All right. Now those are the easy ones. Those are what we call integer equations. That's the easy ones. What do we have down here? What jumps out to you down here in fractions? Yeah, fractional equations. So we all know fractions. We love them, right? Lucy, you shook your head. Yes. Lucy's the oddball. I don't know Lucy at all. We met like 2 minutes yesterday, and that's about it. So Lucy, you're an oddball. You shook your head. Yes. So cool. No grades, so I'm not cool against you. All right. Well, if you don't like fractions, I get that. Let's get rid of them. Let's clear them out. So that's what we want to work on today is how do we clear out these fractions, okay? We want to make it look like the integer equation up above. So to do that, That's what we're going to work on here is the skill. And then this skill is going to follow us through this year, and then really in Algebra 2 they're going to ramp it up. So in Algebra 1 we start learning about the skill of how we can clear out these fractions. Look at those denominators. What are my denominators up there that you see? What are my denominators on number 2 that you see up here? What's my denominators, guys? 6, 5, and 2, right? I see a 6, I see a 5, I see a 2. What's the denominator I don't see, but is there? There's a 1 there, right? So to clear out these fractions, I had to find this magic number that's going to multiply through and get rid of these denominators for me. And it starts by looking at and identifying 6, 5, and 2. The 1 doesn't really do much for us. But you have to ask yourself, you can look at this as one of 2 ways. What is the common denominator for 6, 5, and 2? Or what's some number that 6, 5, and 2 all divide into nicely? Is it? Whoever said it? Oh, thank you, Cordelia. 30, right? 30, right? 30 is that magic number that is the common denominator for 6, 5, and 2. 30 is also that smallest number that 6, 5, and 2 all divide into nicely, right? Now, you've done that many years ago in like 4th, 5th grade, you start working with those. So we're going to take that little bitty piece from way back when and use it to help us out finding that magic number. All right, now with that, let's use it to clear out these fractions. So let's take that 30. The entire equation now is going to get multiplied by 30. Now, we can go about this one of 2 ways. One way is more difficult than it needs to be, and the other way is a little bit easier. What do you think is a little bit easier to do, Bussy, without the aid of a calculator? Do this in your head. Hey, everybody, what's 30 times 47? And then divide by 6. Is that easy to do? No. Can you do this? What's 30 divided by 6? Oh, so we could do that. And then whatever 5 is, oh, sorry, whatever that is, which is 5, I like to put that 5 right there, whatever you get, and take it times, okay, now 5 times 47 may not be as quick and obvious, but I want to divide first. Divide 30 by 6, which is 5. And what is 5 times 47? 235. So we just cleared out our first fraction. Same thing. Divide, and whatever you got, multiply by that numerator. 30 divided by a 1. Does that do anything? No. So 30 times 2x is minus 60x. Okay, keep going, same thing. 30 divided by 5, 6, and 6 times 1 is 30 divided by 2, 15, and 15 times 5x. 75x. And again, you probably could do that in your head, but if not, we get our calculator to help ourselves out. But I always would divide. You can do that division in your head. Multiplication depends on the size of the number. But you said 75, right? Now, which equation would you rather usually work with? This second one we created or the original first one? I'd much rather work with the integer one, that second one, right? So let's work on that skill of clearing out these fractions, because man alive, I would much rather work with that second one. You know how to work with that second one like that. So let's finish this off now. Let's solve out this second one. All right, just like we did on our warm-up there. Okay, you'll get used to it. So from here, 6x plus 75x, right? Right-hand side, I got some like terms to bring together. Do it. Bring it together for me. Solve it out. Don't wait on me. You know how to solve out integer equations. Okay? We want to get you to that step of integer equations that you can just breeze on through with. 6x, 75x gives you oh, it's 81. Alrighty. Get x's on both sides. You know how to move them around. Alright, we're going to get those x's onto the same side. I like to add, what, 60x over it? Gives me 141x, I think. Check my arithmetic. It's always easy to make silly mistakes. And not always, but a lot of times we get off on division, right? 235 divided by 141. This is where our calculators are our buddies. Now, as we did this first hour, and we're doing it right here, 235 by 141, we never give our decimals, okay? Just like we talked about in geometry, we don't give our decimals, we always give exact answers. This isn't a radical, so we're not simplifying radicals, so we have to realize I need to give it as a reduced fraction. But we know our calculators can do it, right? Use your calculator, change it over. What is our button that we use? Just a reminder, math, option 1, right? Change it to fraction. We've done it a ton of times, just as a reminder. What's that reduce on to? Just a simple 5/3, yeah. Just a simple 5/3. So x is 5/3. Okay? So, let your calculator help you out with the arithmetic, and then at the end of that, let your calculator do that reducing the fractions for you. Okay? Alright, rock and roll. Let's go to the next one. Number 3. That is an ugly one. Whether it's got fractions in it or not, there's a lot of terms there. Let's look at those denominators. 8s, 2s, and 6. Somebody.
These are all 2s.
What's that magic number then? You're going the opposite way. You're going down. 24, right? So I want to make sure I can divide into that number. Just 2 divided into 8? No. So Anna actually went the other way. So I'm looking for a number that will divide, that can be divided by everything up there, and it is 24, right? And as I'm standing up here doing, I always like to, hopefully, I like to throw out there what my thought process is. So I always take the large number, 8, and I just start going 8 times 1. That's 8. Does 2 work? Does 6 work? 2 works, but 6 doesn't. Move on. 8 times 2 is what? 16. Does 2 work? Does 6 work? 6 doesn't. 8 times 3, 24. Does 2 work? Does 6 work? It does. That's what I'm going through my head, working through there, trying to find that magic number that works. Take the largest denominator.
What is work?
Divide it into. Does that divide into nicely? So 16, as I said a second ago, does 16 divided by 6 work? No, because I want to make sure when I clear these out that they're going to divide nicely. So 16 divided by 6 is not going to happen, is it? But 24 is going to work, isn't it? So when I say by work, divides nicely. Okay? Nice clarification there. Do it if you haven't done so yet. And as you can probably tell here, there is a lot of opportunities to make some silly mistakes. So take your time. I like to show what's left over. 24 divided by 8. 3 times negative 7n. Yep. 24 times 1. Just because it doesn't have a denominator there, it does. There's a 1 there. It still gets multiplied by 24. 24 divided by 8. 3. 3 times 13n. 39n, right? 24 divided by what? 8. 3. 3 times negative 33. Excuse me. Negative 99 problems. 24 times n. Still gonna do it. It's just a 24n then, right? 24 divided by 2. 12. 12 times negative 3. And then 24 divided by 6. And 4 times 25n. 100. So with that, as I said, there's opportunities for definitely some silly mistakes. But take your time. I would suggest showing that itty bitty work that I did here. Now it takes me a little bit extra time because I'm waiting on replies from you, but it takes at most 15, 30 seconds to clear them out. Clean it up because that is ugly. All right, it's a little bit ugly there. But as we said before, we're all a bit ugly when we wake up in the morning. Don't that look, Grace? better look right now, though. Okay, so left-hand side, got some like terms. Negative 21n plus 39n. Like terms gives me 18n plus 24. Right-hand side, I've got some n's, it looks like. 124n, it looks like. And right here, probably not an obvious one to do in your head, so negative 99 minus 36. Watch that negative, okay? Negative 99 minus 136 is negative 135. Eventually, it all cleans up to be a fairly nice problem. But getting to that point, that is the rough part for today. All right, that's what we're working on. But again, use that calculator to be comfortable with it. Ends on both sides. What end are you going to move, the 18 or the 124? I heard 18, I heard 124. It doesn't matter. All right, we said it doesn't matter. There's definitely more way to go that. Now, I'm in bad habits. I don't say bad habits, but I'm in a habit of always moving the smaller one. The reason why I always suggest moving the smaller one is it limits the amount of negatives that appear. What I mean by that, if I move 124 over, I have to subtract it. I end up with some more negatives. I like to limit the negatives. So what's 124 minus 18 give me? 106. I try to limit the negatives. Negatives we know create extra problems for us, or could create extra problems for us. Add 135 over. 24 plus 135 gives me what? 159. And lastly, back to the calculator bars. That is again not pretty to do, so let the calculator do the work for you. That's actually a fairly nice answer, isn't it? 1.5. 1.5 is what is a fraction? So you should know that in your head. 3 over 2, correct. So 3 over 2. Now with that right there, all right, let's drop it. Let's do one more here. Let's drop it down. Let's do number 5. Okay, let's do number 5, please. And on number 5, I'll be the last one, and we'll flip it to the back side. Come on, erase out. There it goes. One more time. I got a bunch of fractions up there. So find me that magic number that's going to clear it out. Number 5. You're fine. You have number 5. The 12 is correct for number 4. For number 5, what's that sweet spot? 40. Right? It is 40 there. So I heard an 8, which I totally get why I did. Remember, it has to be divisible by all the denominators up there. So 40 is that magic number. So take your time. Let's do that. And again, calculators are nice, but on a lot of these, by dividing first, you don't necessarily have to use a calculator most of the time. 40 divided by 40 is 1, and we can do 1 times 189. 40 divided by 4, 10, and 10 times 3x is, yep. Now here's again opportunity for mistake. Forgetting to multiply by x. It still gets multiplied. There's a 1 there, right? And 40 divided by 1 is 40, still 40x. 40 divided by 5, yep, 8 times 9. Okay, with that last term there, how is that written, that fraction? What's that written as? That's a mixed, right? We need to make sure that's written as a improper, okay? So you need to either mentally switch it over into your head and keep it as that, or then write it down. So what is that mix as a improper? 2 and 4/5 is 14 over 5, right? So 5 times 2 plus 4. You need to change it over to an improper first before we clear it out. So 14 over 5 is what we're working with there. So if you run into a mixed number, which we had not until right now, change it to an improper. Cool, we did that, nothing crazy there. Now cleared out. 40 divided by 5 is 8. 8 times 14 is somebody? 100 and what? 112. That's a plus sign, so 112. Thank you. One more time. It's much easier to work with integers. They're large ones when we have calculators. All right, let's do it off. Finish it off. Right hand side's a bit messy. 72 and 112. 184, absolutely. 184, you said? X's, right? Now again, you can move either X. I like to avoid negatives if I can. So I always move the smaller X. Doesn't mean I'm always doing it perfectly, but it does avoid the negatives. And my experience has been if you can avoid negatives, less opportunities for mistakes. So I'm going to subtract 30x. As I subtract that 30x, what do I have on the other side? Correct. It's just, I like to think it's a good habit. Subtract 184. And what's my answer here? What's my solution? Solution is 1/2, right? 5 divided by 10. 5 divided by 10 is 0.5 or 1/2. 2/4. Yep. 3/6. Let's just stick with the 1/2 there. Yep, but we're good to go. Now, with that skill, it's an algebra 1 skill, and we're going to use it, and algebra 2 is going to build absolutely upon that. So let's take a look at the next side, which is similar, but not quite. Because on the next side, it's a little bit more simpler, where you have a single fraction equals a single fraction. And when you have a single fraction equals a single fraction, well, what do we call that? We call these on the other side, not just necessarily fractional equations, but we call those proportions. So let's see what you remember about proportions here. We can definitely do the same thing we just did, okay? What can we multiply through here by to clear this one out? We can multiply by what? Not 3. 9, right? Yep, you went the other direction, didn't you? Yeah. Fine, simple mistake, it definitely happens. But 9, right? Which is cool, we can definitely do that. But I want us to see what you remember back from your previous teachers. When they talked to you about solving proportions, does anybody remember how your previous teachers reminded you how to solve proportions? We went for the water, so she's not dangerous. There you go. Take that drink, that way you're not supposed to. I know how it goes. I'm going to be drink a lot of water. Coffee, actually. Nice there on this face. All right. And I remember back in the 8 signs here. Not really one of those. What else? This is cross multiply. All right. So you're not getting to it. Do you okay? You can't culture this. Cool. All right. Cool. We'll see you now. Everybody okay? All good space. Okay. All right. So anyway, cross multiplication maybe is what hopefully rings the bell. Maybe what your teacher said back when. Cross multiplication. Cross multiplication is okay. I don't like to use cross multiplication. Cross product is what I'm going to say. Okay. Cross multiply and divide is usually what teachers kind of say, which I don't necessarily like, but we're going to run with it. So, what do I mean by cross multiply? Or what I'm going to say is cross products. Set your cross products equal to one another. What do I mean by a cross product? This right here, 8 times 3. Is equal to, that cross product is equal to the other cross product. Now, the other cross product is going to be 9 times, now I got to take that negative and put it either with the b or with the 3, okay? One or the other, because if I put it in both, what happens with both? 2 negatives make a positive. So it's got to go into one or the other. We talked about that with slope first semester, right? If you did it in slope first semester, what happens to 2 negatives? It makes it a positive. So that negative's got to either go with the b or goes with the 3. I decided to put the b. I don't care where you put it, just not in both of them. All right. So we're going to set our cross products equal to one another, which is like somebody said it, cross multiplication, which 7th grade is about where you start working with that. What's 8 times 3? What's negative b times 9 rewritten as? Yeah, negative 9b, right? Y'all can solve that all day now. What's your move here? Just do what? Divide by negative 9. Do it. 24 divided by negative 9 is not pretty. Change it over a fraction. Negative 8/3. Okay. So with that, we want to get rid of, again, that proportion. And get rid of that proportion is where we're going to set this cross product equal to one another. Okay? So that's the skill we also want to work on. And we are going to use that skill a ton probably in February starting. As I said, at some point in first semester was a lot of congruence. Same shape, same size. Second semester, I said when we move into it, it's going to be a lot of similarity. Same shape, but different size. That's what we're going to be working with. That's going to be used as proportions. So cross products, people. Let's go to the next one. Cross products. 8 times 7. I like to group it and show me that. I like to show that group is literally drawing that cross product of 8 times 7 is equal to the other cross product of what? M times 10. Now, I show that step for you guys. Do you have to show that step? No, you could probably do that in your head. 8 times 7 is 56. Yep, and M times 10 is just 10M, right? And you create yourself a linear equation you guys can get and solve all day. Divide by 10, right? 56 divided by 10 is?
Still ugly.
Yeah, it is going to be, but 5.6 is a nice decimal. I'll take it, but it's 20 over 5. Okay, we tend to work with the fractions there. But our other skill here today is how do we deal with the proportion part of things. Okay.
I love how most of math is basically, hey, you know what you learned last time? Just take that and flip it on its head.
Or extend it out. So the next one. Cross products, set them equal to 3 times that denominator. Its numerator times denominator is equal to the other numerator times denominator. Cross product. 3 times a plus 10 is equal to the other cross product, 4 times a. Now, as I've written up here, I've written it incorrectly. What's incorrect up here? I got you there, Sophia. Parentheses, those things, right? Those things, those parentheses. Right, just like we talked about the Pythagorean theorem first semester. Why you talked about the emphasis around radicals. You got to have that a plus 10. Those two terms have to be multiplied by 3. So as she pointed out there, I got to make sure a plus 10 is getting multiplied by 3. The distributive property is going to do that for us, right? So you got to make sure it's in parentheses to do that. If you do not, you're not going to probably distribute correctly. You're going to leave that as 3a plus 10 instead of what should it actually be now? 3. Correct. So now let's solve it out. And again, you can solve this out all day, every day. We got to get it to that, again, just plain old linear equation for yourself. Cross products, people. 3a plus 30, as Tyler said. Distribute. Subtract that 3a. Yep. And a is just 30, right? There ain't nothing more to do with that one. Okay? Cross products is what we're doing with proportions. Fractional equations is a much uglier one. Cross products is in the back because it's a fraction equals a fraction. Go to the next one. Fraction equals a fraction. Cross products.
Isn't b times b squared?
I hope so. B times b is equal to 3 times 3. Now, Tyler said b times b is b squared. 3 times 3 is? Yep, is 9. Is this a linear equation? Is this linear?
No.
No. This is not linear. Everything else we've done today has been linear. What is this one then?
Exponential.
It's not exponential. We're going to talk about this all on Monday. Quadratic. This is our quadratic because it's squared, isn't it? So we're not going to solve this out like we've been doing here. We're going to readjust things. So we only know one method right now of how to solve a quadratic. The next couple weeks is going to be to our next method. How do we solve our quadratic? Take the square root. Square root both sides. Back to square root both sides because this is a quadratic equation. All right, and what's my solution there? B equals what? B equals what?
3.
B equals what?
Negative.
There you go. You got plus and a minus. Remember, in a quadratic, typically we get how many solutions? Two solutions, right? So we're going to keep both of them because this is a simple algebra solution or algebra equation. It's not Pythagorean theorem, it's not a triangle or anything like that. Now, I say that, but I actually am going to toss one of my solutions. May 16th, I think, is our end of the year. That's the end of the year. That's one date I got in my head. April 15th is the other date. April 15th is PSAT day. Now, PSAT day, the reason why I'm talking about this is what a PSAT question looks like. So on here, when they say if b is greater than 0, if that variable solution is greater than 0, what is that implying? The solution has to be positive. Of my two solutions here then, what solution am I going to keep?
Positive.
The positive solution, correct. That's an SAT question then. As my first hour said, it's phrased a little bit differently, but it's not terribly difficult. But if you're not seeing it, if you're not seeing it, can trip you up on that April 15th day. So we're going to start throwing some more of that out there for you. So 3 is our solution. All right, last one. Take number 10, and we'll call it after that. Cross products equal. It's a fraction equals a fraction. So numerator times that denominator. But b plus 3, it's 2 terms, so what does that mean? And the other one, yep, 7 times 2b plus 1. And what do we know about 2b plus 1? So, parentheses, right? We can solve that again all day long. Should be able to. And again, if you're struggling with those, you gotta communicate it to me. All right, I can get you some extra help. This is the time to ask for after-school tutoring. It's pretty light there, so give me a holler. It's just plain linear. This is not quadratic, is it? Is there a squared up there? Nope. It's back to just our plain linear equations. And again, you can solve that all day long. Excuse me. Somebody got 17 over 6, I think. Yeah. All right. That's what we're going to call it. Okay. So from that right there, these 2 skills we're going to use second semester, so it's a nice place to use that. Talk about it and start using that. So I'm going to